9b exponential graphs. Now we've seen exponential graphs of the type y equals 2 to the power of x, y equals 3 to the power of x, and so on. However, today we're looking at the graph of y equals e to the power of x. And this is actually the exponential curve. So when it's y equals e to the power of x, that's actually called the exponential curve. Table of values for the curve, for the exponential curve, y equals e to the x. So when e is -2, it's e to the -2 or 1 over e squared. When e is -1, it's e to the -1 or 1 over e. E to the power of 0 is 1. E to the power of 1 is e, and e to the power of 2 is e squared. And if we come down and sketch that, so 1 over e squared, if you just look at that on your calculator, when x is -2, y is 1 over e squared, which is approximately 0.135. So we've got -2.135. When x is -1, y is 1 on e. So you can just see what 1 on e is on your calculator. And to do that, you do 1 divided by e to the power of 1, and you get 0.368. So -1 is about just below 0.4. So this would be 0.5 here, so that looks good. -1 is 0.3678. Of course, you can't graph it to the accuracy. When x is 0, y is 1. When x is 1, y is e, which you know is approximately 2.718. So to look at the value of e, you do e to the power of 1. So here I'm just going to put this point that it's 1, e. And when x is, and we know that that is the point 0, 1, and this is the point -1, 1 on e. Okay, so it's good just to label some of those points. And when x is 2, y is e squared. Now that would be here, 2e squared. If you look at what the value of e squared is on your calculator, e squared is approximately 7.4. So that looks fine. That's about 7.4. Okay, now, so that is the exponential curve. Okay, so you can put arrows, all right. Now we can see here that the negative x-axis is an asymptote. So as x approaches -infinity, you can see that y approaches 0. You can see that as x approaches positive infinity, y approaches positive infinity as well. And we can see that the domain is all real x. So if you look across, all values of x are allowed, but the range is that y is greater than 0. So you can fill in this bit up here. Okay, so we've got domain is all real x. The range is y is greater than 0. Now, it says there are how many zeros? Zeros are what are x-intercepts. Where does the graph cut the x-axis? And the graph does not cut the x-axis. So can you just label your x and y axes as well? So there are no zeros. The curve is always above the y-axis. So the x-axis is a horizontal asymptote. So the x-axis, as we said before, is a horizontal asymptote on the left. So the x-axis isn't a horizontal asymptote on this side, it's a horizontal asymptote as x approaches -infinity, y approaches 0. So here we can write, as x approaches -infinity, y approaches 0. I can put a little plus there saying that it approaches 0 from the positive side. And on the right-hand side, we can see that the curve increases steeply. Okay, it increases steeply, and as x approaches positive infinity, y approaches positive infinity as well. Okay, now the gradient of the curve, there's a little statement here, the gradient of the curve always equals the height of the curve above the x-axis. Now, the reason they're saying this, when you substitute in an x value into here, you get a y value, okay? But since when we differentiate y equals e to the x, we get dy dx is also e to the x. So that means we know that y equals e to the x, but dy dx is also equal to e to the x. So therefore, if I look at a point here, this is the point 1e. I know that when x is 1, y is e, but because dy dx is also equal to e to the x, I know that the gradient at x is 1 is e. I know, for example, here when x is 0, y is 1. So we can just write that here, for example. So we know that when x is 0, y is 1. And since dy equals dy dx, so because we know that y equals dy dx, which equals e to the x, so when x is 0, y is 1, but we also know that dy dx is 1. Now dy dx is the gradient of the curve, and so if y equals 1, dy dx equals 1 because y equals dy dx, which equals e to the x. So this is what they mean by the height. So here the height of the curve is 1, but that's also the gradient of the curve here, the gradient of the tangent to the curve. Okay? Okay, now we're going to look at sketching. If you could please do a table of values here for y equals e to the x plus 2 and y equals e to the x minus 1 and sketch the curve. Look, you should already know from previous transformations that we've looked at that this would just be the graph of e to the x shifted up 2 units, so you should get that. And this one here, y equals e to the power of x minus 1, that is the e to the x graph shifted down by 1 unit. Okay, now just filling in your table of values, or what you could do is actually just look at the graph and do everything 2 units up, and for this one everything 1 unit down. But if you do use table of values, e to the negative 2, so when x is negative 2, it's e to the negative 2, or 1 over e squared, and then we've got to add 2 to that. E to the negative 1 is 1 over e, add 2 to that. So it's 1 on e plus 2. E to the power of 0 is 1. 1 plus 2 is 3. E to the power of 1 is e, plus 2 is e plus 2. And sorry, I thought the recorder was on, but it wasn't. And when e is 2, you get e squared plus 2. So as I said before, if we can then go and sketch that, and that will be the blue curve up here. Okay, so you can just plot all those points. They will be 2 points above the other curve. You may want to indicate a few points on the curve. For example, this is the point 1, comma e plus 2, and so on. Okay, and then we've got this point here, which we can see is 0, 3. And on the other curve as well, this, for example, is the point 1, e minus 1. So you can do table of values for both of these. As we can see, both graphs have domain all real x. With the graph e to the x plus 2, which I've done in blue, you can see that the range is y is greater than 2, and we can see that the line y equals 2 is your horizontal asymptote. So this, the blue curve, is y is e to the x plus 2, and the red curve here is y equals e to the x minus 1, okay, which is shifted 1 unit down. The black curve, or the original curve there, was e to the x. So we can see our horizontal asymptote here is y equals 2, but for the red curve, which was shifted 1 unit down, horizontal asymptote is y equals negative 1, and notice the range is y is greater than negative 1, but the domain is still all real x. And here on the blue curve, y equals e to the x plus 2, as x approaches negative infinity, y approaches positive 2. And with the red curve, as x approaches negative infinity, y approaches negative 1 from above. And this approaches 2 from above. And as we said before, this graph is e to the x shifted 2 units up, and this graph here is e to the x shifted down 1 unit. The next page, we've got some other shifts, and you should recognize these as sideways shifts. So I've just chosen the values here so that we'll get some nice values coming out with some of these values here. So when x is negative 2, we've got e to the negative 2 minus 2 is e to the negative 4, which is 1 over e to the power of 4. When e is negative 1, we've got negative 1 minus 2, that's e to the negative 3. Now they're very small. When e is 0, you get e to the negative 2, or 1 over e squared. When e is 1, we get e to the 1 minus 2, e to the negative 1, or 1 on e. When e is 2, we get e to the 0, which is 1. When e is 3, we get e to the 3 minus 2, which is e to the 1. And when e is 4, you get e squared. Okay, now domain is, remember, this is just e to the power of x shifted to, you have to work out whether it's shifted to the right or the left. I think, well, we think it is shifted to the right by 2 units, because when it's -2, you're shifting to the right, okay? But let's have a look when we draw it, okay? So the domain should be all real x, and the range, it's only a sideways shift, so y should be greater than 0, and the line, well, it's actually the x-axis, you might want to write, so the x-axis is the horizontal asymptote, or you could write it as the line y equals 0 is the horizontal asymptote, and as x approaches negative infinity, y approaches 0 from above. So let's have a look, let's sketch that. Y equals e to the x minus 2. So when it lies, we've got when x is, let's just do some of the bigger values. When x is 4, y is e squared. Now e squared is approximately 7.3-ish, so it's this value here. Okay, remember it's been shifted. So we've got the curve y equals e to the x there first. Sorry, you can't see what I'm doing. Okay, 1 minute. I'll just focus. So here we've got the curve y equals e to the x. Okay, and we're saying that y equals e to the x minus 2 is a curve shifted 2 units to the right. So we've looked at these values. When x is 4, y is e squared. When x is 3, y is e. So let's just plot those points first. So when x is 4, e squared is about 7.3. And the other point on this is y equals e to the x here, and this was 2e squared, and over here we had the point 1e on the original curve. That is y equals e to the x. Okay, now this curve should be 2 units shifted to the right, so we're getting when x is 4, y is e squared. When x is 3, y is e, which is about 2.7. When x is 2, we get that y is 1. Notice this is a 2 sideways shift by 2 units. When x is 1, y is 1 on e. Now 1 on e is about 3.7, which is about here. You can see that's a 2 sideways shift of 2 from this position here. Okay, and again we'll have a sideways shift by 2 again from there, and so on. Look, I can't really plot these, they're just too close to the axis. So there is your graph of y equals e to the x minus 2. Okay, so you can sketch that in, and then you can fill in everything we've got there. So that's just an asymptote, just be careful there. Okay, so we've got y equals, sorry, this one's a bit big, this graph. Y equals e to the x minus 2, which is a sideways shift of 2 to the right. And if you can also maybe sketch in red, y equals e to the x plus 1. So that should be a shift of left by 1 unit, and you can put all these values in. Okay, I'll just let you do that, and we'll check your answers in a minute. Values in the table, and then just come below and check your sketch as well. And notice here that the line y equals 0 or the x-axis is your asymptote. So when you come down and draw it, everything is just going to be 1 unit to the left of where it was. So when x is 0, we now have that y is e, which is 1 unit to the left from there. When x is -1, y is 1, which is 1 unit to the left from there. When x is -2, we've got 1 on e, which is about 0.36, and so on. So these values are, that's your asymptote here. And when x is 1, you're getting e squared, which is about 7.3-ish, so it's 1 unit shift to the left here, and so on. So you can just join those points up and label your graph. For example, here I would put at when x is -1, I've got -1, 1. That's a definite point to label. Here I would put this as 0e, okay? And on the other curve, just make sure that you're labeling a few points. Here I've got 3e, and here I've got the 0.21, so just making sure that you're labeling those, okay? And here on my original curve e to the x, I've got 0, 1. So we can see that sideways shift of 2 to the right for e to the x minus 2, and that sideways shift of 1 to the left for e to the x plus 1. Okay, now next page, you shouldn't really have a problem with this. The curve y equals e to the x is already sketched there for you, and you just have to sketch y equals e to the negative x. You should recognize this as a reflection in the y-axis. So you can fill in your domain and range. Your x-axis is an asymptote. Really, it's an asymptote here on the left. But for the other curve, which is reflected the other way, the x-axis will be an asymptote on the right. And you can just fill out the rest. But just noticing that it's reflected in the y-axis. And you've seen this before with other exponential curves. So that's your graph of y equals e to the x. You can just make sure that you mark in a few of the main points. So we've got 1e, 0, 1, we can see we've got negative 1, 1 on e. Okay, and we've got 2e squared there. Okay, and if you can just plot the other one and check when you're done. And yeah, it's just going to be a reflection. So this will be negative 2e squared. This one will be negative 1e. We'll still have 0, 1. We'll have 1, 1 on e instead of negative 1, 1 on e, and we'll have 2. We'll have, 2, 1 on e squared, which is about down there. So the curve is going the other way. And just you can label in your axes as well. You've got your x-axis, label the main points, and your y-axis. Okay. On the next page, you're sketching y equals negative e to the x. So you've got to recognize which way e to the x is reflected this time. It's just going to be the negative of all those e to the x values. So if you just look at your e to the x values, you're just going to put negatives in front of them. So it's going to be reflected not in the y-axis this time, but in the x-axis. Now, just being careful there with your domain and range. You might want to plot it first and then come back and fill all this out. So you can fill in your table of values. That's what you should have. Okay, shouldn't have a problem with that. And it's just a reflection, in the x-axis. So once you sketch a curve, it should look like that. As x approaches negative infinity, y approaches 0 with a little minus there, meaning from below. So it approaches 0 from below. The range, again, is y is less than 0. So all the y values are less than 0. Here you can put in just a few points. If you're ever sketching, you always need to mark in a few points on your curve. Okay, so that's your curve y equals negative e to the x. Now just one more curve here. So we've got the curve y equals e to the x there already. Now you need to do a table of values and sketch y equals negative e to the negative x. So it's got that negative in front, so it's going to be below the x axis, but looks like your x values are going to be reversed because on the last page we already sketched e to the negative x, so it's just going to be the negative of that. Yes, you should get that. And now sketching it, we've got when x is negative 2, y is negative e squared, so down here. And when x is negative 1, we've got y is negative e, which is about there. When x is 0, y is negative 1. When x is 1, it's negative 1 on e, which is about there. And when x is 2, it's about there. So just sketching your curve. So this one is y equals negative e to the x, which is a reflection of e to the x. So that one was reflected down. Okay, and then this one, the red one, is the blue one reflected across the y-axis. So this is y equals negative e to the negative x. And you can just put a few values there on your curve. Okay. All right, so coming back up, we can see that y equals negative e to the negative x. This is the graph of e to the x reflected in both the x-axis and the y-axis as well. So it's a double reflection, okay? Now, there are two more graphs here, and they're a little bit more complicated. So one of them is what you really need to do, you want to, we've got the two different graphs, and I know on this graph I've got a few different curves, but it shows how you get the final curve. So what you've got to do when you come to sketch something like this, you've got to say, well, you start with e to the x, right? So you start with the original curve e to the x. Then you realize that that curve has been, it's now negative e to the x, so it's being reflected in the x-axis. That's what the negative is for. And then this 2, so this is like plus 2, so then that curve has been shifted up. So you can come down to the three curves down here, and you can see how that final curve has been created. Now we recognize this as y equals e to the x. This other dotted line down here, so this other curve down here that's dotted, that is y equals, negative e to the x. So that's y equals negative e to the x. So I want you to label them. And then it appears that this curve was shifted up 2 units. So the final curve, the solid line curve, is the one that you want. That's your curve. So that curve is y equals 2 minus e to the x, because it's minus e to the x or negative e to the x shifted up 2 units. Okay, so that's why the three curves are there. So when you come to sketch something like this, that's the process that you need to go through. You look at e to the x, and then you reflect it in the x-axis, okay, and then you shift it up 2 units. So this is the graph of y equals e to the x reflected in the x-axis and shifted 2 units upwards. Okay, now you can see the final curve there. If you want, you can do your table of values, but you can see, because we have that shift 2 units upwards, that we have here, and I've just dotted it, this is y equals 2. It is the horizontal asymptote, okay? So it's your horizontal asymptote is y equals 2. So the range of your curve, that's your final curve, the solid line, it has a range of y is less than 2. Okay, it has a domain of all real x, and the line y equals 2 is your horizontal asymptote. And as x approaches negative infinity, we can see on the curve, as x approaches negative infinity, y approaches 2, and little minus, meaning from below. Okay, and you can just do your values. This would be 2 minus e squared. That would be 2 minus e. That's 2 minus e to the 0 is 1. So it's 2 minus 1 is 1. So looking at that main point there. Now we've got 2 minus e to the negative 1 is 1 on e. So it's 2 minus 1 on e. And this would be 2 minus 1 on e squared. Okay, so you can just mark out a few of those points. We can see we've got the point 0, 1, and we've got the point here 1, 2 minus e, okay, and you could put a few others if you want. And same thing over here. When you come to sketch something like this, you've got to think, how was this created? Now, actually, I think we want, one sec. I think what we want to say here, I don't want to say that. I want to say that this is the graph. You would really start, with e to the x. So you should really say, this is the graph of y equals e to the x reflected in the x and y axes. So this would be e to the x. Reflected in the x-axis makes it negative. Reflected in the y-axis puts a negative here, and then shifted 1 unit upwards. Okay, so we start with, and I actually haven't put it there, but you can see this is y equals e to the x. So that is this one reflected in the y-axis would be y equals e to the negative x. And then that is shifted down. So that's y equals e to the negative x. That's shifted down, so that's the dotted one down here. So the dotted one is y equals negative e to the negative x. And then that is then shifted up. Sorry. And look, that obviously has been shifted up 2 units. So can you just go back and change this to 2 minus e to the negative x? So that's clearly been shifted from this dotted line up 1, up 2 units. So this graph here is y equals 2 minus e to the negative x. All right, so let's just see with the table of values. Let's just check out the point when x is 0, for example. So when x is 0, you get 2 minus e to the 0, which is 2 minus 1, which is 1. So we should have the point 0, 1, and we do, okay? When x is 1, we've got 2 minus e to the negative 1 is 1 on e. So it's 2 minus 1 on e, so that should be about 1.7-ish, and it is, okay? And so on, you can just complete these. So that would be 2 minus 1 on e squared. This would be 2 minus, now e to the negative 1 is just 2 minus e to the positive 1, which is 2 minus e. And this would be 2 minus e squared. Okay, I'm just checking those on the graph. Yes, and those points look correct. Okay. Okay, and if you can just fill in your table of values and just check your answers here, you should be fine. And sorry about that. That is y equals e to the x reflected both in the x and y axes, all right, and then shifted 1 unit. Sorry, 2 units. Sorry, that's wrong. 2 units upwards. Okay.